Today we'll be learning about factor theorem. Okay, we'll just learn what factor theorem is. Okay, earlier we just studied what polynomials are, and we also did some basic operations on polynomials like addition, subtraction, multiplication, and at the end we studied division of polynomials. Okay, so our next topic is the factor theorem. So we'll just understand what factor theorem is all about. Let me guide you through factor theorem through an example. Okay, so suppose we have a polynomial as 4x cubed minus 8x squared minus x plus 2. Okay, you have a polynomial px is equals to 4x cubed minus 8x squared, this is 8, minus x plus 2. Okay, now if I ask you that you have to find the value of this polynomial at x is equals to 2. So what is the value of this polynomial at x is equals to 2? So we'll just find out p of 2, will substitute x is equals to 2 in this polynomial. So this is equals to 4 into 2 cube minus 8 into 2 square minus 2 plus 2. So what will be the value of this? P2 will be equals to 4 into 8 minus 8 into 4 minus 2 plus 2. So this will be equals to 32 minus 32 minus 2 plus 2. So this will be equals to 0. So we know that P of 2 is equals to 0. So we can say that the value of px, okay, the value of px at x is equals to 2 is 0. We know that p of 2 is equals to 0. So in other words, we can say that when suppose you have this x is equals to 2, suppose you take this and you shift this 2 over here, so it will become x minus 2 is equals to 0. This polynomial, it will become like this. So we say that when p of 2 is equals to 0, when p of 2 when p of 2 is equals to 0, then we conclude that x minus 2 is a factor of px. Okay, so it means that when you'll divide this polynomial by x minus 2, then the value of this polynomial or the remainder of this polynomial will be 0. So it means that x minus 2 will exactly divide this polynomial, which means that your remainder will be 0. So a factor theorem says that, so we can just rearrange it and write it. So a factor theorem says that if for any polynomial px, for any polynomial px, if p of c is equals to 0, then x minus c is a factor of px. X minus c is a, this is a factor of px. Okay, so this is your factor theorem. For any polynomial px, when we put this x minus c, so suppose x minus c is, suppose you have to check that x minus c is a factor of px or not. So what you will do, you will just x minus c is equals to 0, you will just find out the value of x from here and you will put it in this equation, you will put it, you will put it in this polynomial, and if that polynomial value at this point is 0, then your x minus c is a factor of px. Okay, so this is how your factor theorem works. Okay, so this is basically your factor theorem, and the vice versa is also true. For example, let us take one more example. Suppose you have a polynomial. Suppose, okay, let's take the same polynomial. Suppose you have px is equals to 4x minus, okay, let's take a different polynomial. 4x cubed minus 2x squared plus 8x minus 4. Okay, and you have to check the value of this polynomial at x is equals to half. Okay, so what we'll do, we'll find out the value of at x is equals to half. So when you will find out this value will come to be 0. Okay, so when you will put x is equals to 1 by 2 in this equation, you will get p of half is equals to 0. So the value at x is equals to half, the value of this polynomial is 0. So we can say that x minus half is equals to 0. So x minus half is a factor of this polynomial since the value at x is equals to half is 0. So we know that x minus half is a factor of this px. But now when you rearrange it, if we rearrange it, we take the denominator, we take, these are fractions, and we take the LCM of these two. So it will be 2x minus 1 upon 2 is equals to 0. So 2x minus 1 is equals to 0. So we can say that 2x minus 1 is a factor of px. Okay, so this is our factor theorem. This is our factor theorem. Okay, so by factor theorem, you can solve all questions, and you can also check if a certain, at certain points, whether a particular polynomial is a factor of another polynomial or not. Okay, so let us take one more example. Okay, we'll take one more example so that you will get a clear understanding of it. Now you have a question, or like, show that x minus 3 is a factor of x cube minus 6x square plus 11x minus 6. X cube minus 6x square plus 11x minus 6. Now you have to show that x minus 3 is a factor of this polynomial. And they have asked you to show it by, first is algebraic division. Okay, algebraic division. And the second is you have to show that this is a factor of this polynomial by factor theorem. Okay, by factor theorem. So this is your question. You have to show that x minus 3 is a factor of x cube minus 6x square plus 11x minus 3. First part by algebraic division, and the second part is by factor theorem. So what we'll do, we'll just first perform the algebraic division, and we'll just check if this expression is divided exactly by x minus 3. Okay, so what, how we do, how you always remember, like you have remembered in the previous lecture, that how we perform divisions of such type. So what we'll do, we'll take the first term of a divisor x, and we'll take the first term of a dividend x cube. So what should be multiplied in x to get x cube? X square. Okay, we'll write here x cube, and similarly we'll just multiply the second term with the quotient. So what it will be? Minus 3x square. Minus 3x square. So we'll reverse the signs, minus and plus. So what we'll get? Minus 6x square plus 3x square is minus 3x square. Now we'll bring this down, plus 11x. Now what should be multiplied in x to get minus 3x square? Minus 3x. So this will be minus 3x square, and we'll multiply minus 3 and minus 3x, so it will be minus 9x. Reverse the signs. So what you will get? 11x plus 9x is 11x plus 9x is, sorry, this will be plus of 9x, so this will be minus. Okay, minus into minus is plus, so plus of 9x. So 11x minus 9x is 2x. Now we'll bring this minus 6 down, 2x minus 6. So x, when what will be multiplied to x to get 2x? Plus 2. Okay, so this is 2x, and minus 3 into plus 2 is minus 6. We'll just reverse the signs, so you'll get 0. Okay, you'll get 0 over here. So when divided algebraically, the remainder is 0. So x minus 3 is a factor of this polynomial. X minus 3 is a factor of this polynomial. X cube minus 6x square plus 11x minus 6. Okay, so this is the method of algebraic division. Okay, we have shown that x minus 3 is a factor of x cube minus 6x square plus 11x minus 6 because it is completely divisible by x minus 3 because remainder is 0. Okay, now we'll just go for the second method. Okay, the second method, which is a much smaller method, it is better than your algebraic division method. So we will assume let a polynomial fx is equals to x cube minus 6x square plus 11x minus of 6. Okay, Now we know by factor theorem, like we have to check for x minus 3. Now we know by factor theorem that if f of 3, why f of 3, when we'll put this is equals to 0, so you will get the value of x is equals to 3, hence we have put here f of 3. So if f of 3 is equals to 0, then x minus 3 is a factor. We have learned this through our factor theorem. Okay, so we'll just check if f of 3 is 0. If our f of 3 is equals to 0, then x minus 3 is a factor, otherwise it's not. Okay, so let's check the value of the polynomial at x is equals to 3. So we'll put 3 in place of x. So f of 3 is equals to 3 cube minus 6 of 3 square plus 11 into 3 minus 6. Okay, so 3 cube is 27 minus 6 into 9 is 54 plus 33 minus 6. So when you'll solve this, you'll get 0. So f of 3 is equals to 0. Now since f of 3 is equals to 0, therefore x minus 3 is a factor of fx. Is a factor of fx, which is our polynomial, for which we have to check whether x minus 3 is a factor of this polynomial or not. Okay, so this is how we do questions. Okay, we check if a particular function or a particular polynomial is a factor of another polynomial or not. Okay, so there are two methods. One is your algebraic division method, which is your long method, and the other method is your factor theorem method. Okay, which is a shorter method and an easier method.